Hi guys and gals. Today I would like to show you how to create a 2D space shooter in jMonkeyEngine, and I'm using Galago framework, which is built on top of jMonkeyEngine. So this is the first time I'm doing a video like this. Please bear with me. It might get rough. So basically what I'm gonna do is explain to you an existing game I created. I'll show you the main features of Galago, the framework Galago, and then also what approach I took in creating this game. First off, I've created the basic game, and this game will reference libraries. It will reference the Galago library. It depends on Twin Engine and Din4j. Din4j is a 2D physics engine. Twin Engine is for GUI manipulation. Well, basically any manipulation you want over time. Okay, so under Space Shooter I've got project assets. Project assets we're going to use will be enemies, which will be the enemy spaceship, laser, meteors, and then various spaceship pictures. Then we also have sound effects, which we will be using. Under models, I've placed a Starfield particle emitter, which I've also developed in jMonkeyEngine, using this wonderful tool at the side, which is built in, as well as some explosion effects, such as a bullet explosion, enemy explosion, and a player explosion effect. Then we'll have materials, which will link to each one of those sprite sheets and textures we have down there. Player, yeah, those are all the materials we're going to use. Then we also have interface. I think I basically only use the blue button. We can change it out to use any one of those. Red, blue, green, depending on what your look is going for. And then a nice little font, futuristic font we're going to use. Alright. If you go into the code, you'll see my package name, package structure. I've got my main application. Main application extends a class I've created, an abstract class called base 2D application. What this does, it tells the engine that I'm going to use 2D physics, might use 2D physics, and also only render in 2D mode. There's a few methods you have to implement. Here you'll give it a title, a native resolution, a name for the save file, a font. This will be, if you want a splash screen, you can add a splash screen image, and also whether it must ask you to change the resolution, so if it's resizable. And then you just call that this class, instantiate this class. Then you've got pre-initialize, post-initialize, if physics must be enabled or not, and then from there on. Okay, so if you look at my class structure, my package structure, if you look at the source code and you look at my package structure, you'll see I have a few packages naming each aspect of the game specifically. For example, I've got my root package, which is where my main application class is. I will have a bullet package. I've got my enemies. I will have player, screens, and UI. And the main application, you'll see I extend a class based to the application, which is defined in the Galago framework. It tells the game engine that I'm going to develop a 2D game which might use physics or maybe not. In the constructor for this base 2D application, you need to give it a title, a native resolution which is going to be fixed. Depending on what resolution at runtime is, it will scale around this resolution. Then you give it a player save file, a font, which is a default font, and then you can give it an image file for splash image, and then if you want to allow the user to resize his game window, you can give that a property of true as well. Then you have a pre-initialize, post-initialize method. Physics is physics enabled property. If you want to use physics, you return true. Then there's an initialize screens method, initialize models, initialize sounds, initialize effects, textures, and that's it. So basically all these initialization methods will pre-initialize things you're going to use in the game. This allows you to pull in repetitive stuff into memory. For example, I've got 6 screens. Got my menu screen, got a play screen, option screen, about screen, game over, and game completed screen. So basically each one of these screens will have a specific function. If you go under bullet, we will have a bullet collision control and a bullet control. Enemies will have an enemy collision control, enemy movement control, enemy shoot control, and basically the enemy spawn control, which will be the main controller spawning enemies from the positive y-axis. Next, there's a player collision control, player movement control, and also a player shoot control. Up next we have the screens. About screen, well, let's run the game and we'll have a better idea of how the screens are structured. So here we have the game running. See, you have your play screen, options, about, and exit is just to exit the game, start a new game. You see we've got various enemy types. Oh, got 2 lives left. Those enemies can shoot back. Oh, see, and now it goes to the game over screen. Let's go back. If we go to the play screen, we have a class called abstract screen that we have to extend. This screen has a few methods that you need to implement. We've got the initialize method, which will be called once the game is started up in that main application. This is where you initialize your GUI components or your HUD. Then as soon as the screen is activated to be shown, there will be a load method being called, and then after the load is called, a show method will be called, and then as soon as the screen exits again, exit will be called. And if you run this on a mobile device and the screen locks, a pause method will be called. So let's see what we have in this class. We've got our label as UI components. We've got a live label, kills, and then a ready label. As you can see, all of them are initialized in the initialize method. So when we load the screen, we want to load everything from scratch. This is where I initialize the star field. I attach it onto the root node. I spawn a player and I initialize an enemy spawn control. So in the spawn player, I create a sprite, a spaceship sprite sheet, a sprite image, which we will use this method, give it a name, a width and a height, and then the columns in a row is the size of the sprite sheet, and then index will be the index that image or that sprite is on, that specific tile. It will be from top left side to right down. So we're going to take the first spaceship in this image. Let me show you. We'll be using that spaceship picture. Then we add a rigged body. After the rigged body, we will add a player movement control, add it to the input listener, add a joystick listener, player collision control, which will determine collisions in this physics 2D world, and a player shoot control. And then here we add a control which will basically count down and the enemy to be after the player to become ready and start playing. So only here, once the countdown is finished, we set it to active and add the player shoot listener, and also the joystick shoot listener, and play a sound effect to say the shield is up. Then we go back when show method of this screen is called. We attach the enemy spawn control and add this class to a message manager. The message manager will basically fire messages to all listeners all over the game. So in case you have a game over event, okay, it will receive this message game over, and you can show the correct UI, detach or remove listeners, and show the game over screen, or respawn the enemy, the player, or go to the game completed screen if you killed all enemies. And how do I send a message? Well, it's easy. You go to player collision control, which extends by abstract control, physics collision control, and if that collision happened between enemy and player, or bullet and player, I set a property to game over, and we remove this listener from the physics space, do a player explode effect, player die sound, remove it from the physics space, remove it from the root node, and then we send a message saying game over. So because this player screen is added as a message listener, it will receive this message and do this correct functionality. So inside the enemy spawn controller, I create an array that defines the levels. Each one of these integers is a specific type of enemy. We've got a 0 is basically a normal straight enemy that goes straight down. We've got 1 which is a zigzag enemy, and then we've got a 2 which is zigzag and aggressive. Aggressive just means he can shoot back. And then finally, the big boss, we have a mothership. In this controller, we load the enemy's sprite sheet material, and we have a timer that counts the adding of enemies. Here we add some sort of enemy, a type of enemy, depending on which is next in the array, and load the sprite sheet or the sprite image, attach it to the root node, create the rigid body, add it to the physics space, add the enemy movement control, add the enemy collision control, and then if the enemy can shoot back, add the enemy shoot control. And that is how easy it is to add an enemy. So you may ask, how do we control the player? Well, that's easy. If we go to the player movement control, you see it's an abstract control, but it also implements action listener and joystick listener. In here we have 4 Boolean values, left, right, up and down. We've got a vertical speed and a horizontal speed. If the keyboard action move up or move down or left or right is pressed, the appropriate method will be called and the appropriate action will be performed. You get a rigid body and you move it in either in the y-axis or in the x-axis. And in the case of joystick being pressed, if up is pressed, you move it up or down, left or right. Same goes for the player's shoot control. It's also, it implements the analog listener and the joystick listener. If the analog shoot button is pressed, fire a bullet. We take the spaceship sprite, clone its position and add 2 so that it fires in the positive y-axis. Here we initialize a new sprite bullet, add a rigid body, play a laser sound and add the bullet control, which handles the movement, and the bullet collision control, which will handle explosion and collision of that bullet. So if we go back to the UIs, let's say for example the menu, you'll see we create 4 different buttons. These buttons extend a button called touch button. Now a touch button is specifically designed to work on a touchscreen device or using your mouse, or you can use your up and down arrow keys and left and right arrow keys if that touch button is added inside a button panel. You define the sizes, touch effect, and add some other specific effects. So I advise you to please go and check out this project, see what I've done, and see how easy it is to create a game. Well, specifically a 2D game. In my future videos I might cover 3D games and also maybe specific type of games I do. Let's see what happens. I hope you enjoyed this video, and please leave any comments below. Thank you.